Hi there. So in this lesson about functions, there's a lot of different types of things that they talk about, a lot of terminology that's new to us, and some of it's kind of obscure, like why do I care? Why do we worry about some of this stuff? And so I'm going to try to do two things here. I'm going to try to hit on all the little different types of things that they're asking you to be able to do, but I'm also going to try to give you some perspective as to why we might care about this. All right, so let's start off with just like a real life example. Let's say Carson, my son, he's having a birthday party and he's going to go to All-Star Sports. And so we're kind of thinking about, well, how many kids can you invite? Because it's going to get expensive for me. And so, because I got to buy tokens for everybody. So let's say that I tell him, well, let's kind of look at what we would do. So if you invited, let's say 3 kids, or let's say it's you and 2 kids for a total of 3. So you're just going to bring 2 friends. There's 3 kids now. And if we do that, let's say I'm going to buy 30 tokens for you guys. All right, but if you want to bring more kids, I'm probably going to need more tokens. So if you decided to have 4 kids at the party, then maybe I'd get 32 tokens. Or if you're going to bring 5, I want it to kind of divide out evenly, so I'm kind of changing these numbers so it'll divide nicely. Okay, this is called a relation, and that's what this whole section's on, is relations between different things. Now, in this example, you don't need to take notes on this, though I would recommend you take notes, because there's, like I said, there's a lot of different things, but don't worry about taking notes on my birthday party example. Just know that we're going to kind of keep referring back to this scenario of having to buy tokens. So this type of problem is really what you're going to see in the software. So this would be something maybe you would want to take notes on. And so the first thing they might ask you is this says list the ordered pairs corresponding to the points in the graph. Okay, so that's just looking at points and being able to write their coordinates. Okay, so remember when you have these ordered pairs that this is your x value and your y value. So when I look at point A down here, my x value tells me where I'm going along the x-axis. So from the origin, always start at the origin here, and looks like I need to go -7 units to the left along the x-axis. So the coordinate for A, for the x-coordinate, would be -7. And then it also has to go down along the y-axis. The y-axis is vertical, and it looks like I have to go down 9 units. So the y-coordinate is -9. All right, so I've got A. Let's just kind of do these other ones real quick. So B is down here. All right, so from the origin, I would not have to move along the x-axis at all. So the x-coordinate is 0, but along the y-axis, I have to go down 8. That'd be -8. Okay, do you think you could figure out your coordinates on C and D? That's my hint. Go ahead and try it. What do you think C would be? Okay, hopefully you're thinking I got to go -1 along the x-axis, and then I got to go vertically -2. All right, same thing with D. On this one, along the x-axis, I'd have to go -1, and then vertically I'd have to go up 7, it looks like. So those would be the coordinates. So that's just plotting points kind of thing. That's the first type of problem that they have. On my previous example in the birthday party, I wrote these kind of like as in a table instead of as points in an ordered pair. That really is the same thing. It doesn't matter how you write those. Okay, so now the next thing that they talk about, they use these terms domain and range. And your domain is all of your possibilities for your first coordinate. So in this, my first coordinate represents my number of kids. Okay, so my domain, my options here is I could have 3 kids, or I could have 4 kids, or I could have 5 kids. And that's the domain, the possible values there. So your range is always your possibilities for your second coordinate, or your y values, or in this example, it's the number of tokens. So my options for my number of tokens would be 30, or 32, or 35, and that would be my range. Okay, let's give it a try with something that you're going to see in the textbook or on the software. Okay, I'm going to use that same example that we just had with all those points we just plotted. Now your domain, and now I'm up top, and so this would be something maybe you want to take notes on. The domain is always going to be the possible x values. So you need to remember that domain goes with x. And your range is always your possible y values. Okay, so if I look at this, it's really probably easiest to look at my ordered pairs that I've already listed rather than the points in the graph. So my possible x values, and actually let's read real quick the directions up here, what it says. It says determine the values in the domain and range of the relation. This is important right here. Enter repeated values only once. So if you ever end up with the same x value more than once or the same y value more than once, you don't actually list it more than once. These are just your possibilities. So when I'm doing my domain, remember that's my x's, so I'm looking at all these numbers right here. So it looks like my possible x's would be -7, 0, -1, and there's no reason for me to write the next -1. Don't repeat that. So there's my domain right there. So what do you suppose your range is? Well, it's your possible y's. It's all these numbers right here, right? Do you see any repeated values on that one? I don't, so I'm going to have to list all of those numbers as my range. Okay, so finding domain and range, that was another thing that is brought up in this lesson. All right, the third thing is determining whether a relation is a function or not. Okay, so here's kind of my real life example of why this is important. Don't take notes on this, just let this make sense in your head. So let's say I've talked to Carson about, okay, here's kind of what your options are, Carson. And he says, oh, by the way, Mom, Carter can't come to my birthday party, but I'm going to bring Isaac instead. And so I'm sitting there thinking, okay, all right, so that means if Carter's not going, and I'll talk all fancy and say a lot of howevers and well then and thus and come up with the fact, all right, so if you're going to bring 3, then I'm going to bring 27, I'm going to get 27 tokens. Now, that creates a problem. Carson's no dummy. He's going to look at that and say, well, but Mom, up here, you said if I brought 3 kids, I'd get 30 tokens. Why now when I bring 3 kids, I'm only getting 27? Okay, so that creates some confusion, I guess. And so a function is really a rule. So these are all relations, and this is a beautiful relation right here. But is it a function? Well, for it to be a function, it has to follow a rule where there's no confusion. And so in this, it creates confusion. If I'm bringing 3 kids, am I getting 30 tokens or am I getting 27 tokens? That creates confusion. So that's a no. This is not a function. Now, if I had only used these, that would have been fine. That would have been a function. But as soon as I threw in that extra one, and this is what it is, what you don't really want to have happen is have this x value go to more than one y value. So in this case, 3 might mean 30 tokens, 3 might mean 27 tokens. That's confusing. So you don't ever want your x values to lead to different y values. Okay, so let's look at something that would be from the textbook. Okay, so let's go back to our same example that we had, and we're looking at this. Did we ever have an x value that led to different y values? So this -7 that I have here led to -9. Did I ever have another -7 that went to something different? Well, nope, I didn't. This 0 goes to -8. There's no other zeros that go to something else. This -1 leads to -2. Okay, that's fine, but now I have a -1 that leads to a 7. Now I have some confusion. I have a problem there. And so this would be an example of something that is not a function. This would not be one because, and I always kind of think of it as if I ever have my x's repeating, I know I'm going to have trouble. You don't want those x's to repeat because then they're going to be leading to different y values. Let's take some notes on this. So what you kind of want to say is something like this. Is it a function? And to find that, basically you have to say, and there's a lot of fancy textbooky definitions of what a function is. I just want it to make sense in your head. Is it a function? Each x needs to lead to exactly one y value. Or another way to think is x's can't repeat. If your x's are repeating, that's a problem. Okay, so you might pause the video, take some notes on that so you have that. Then since there's so many different things in this, it's kind of important that you kind of have something to look back at until it all makes sense in your head. So pause if you want. I'm going to move on. Okay, so this is really pretty easy to do when you look at a table. You're basically just saying, hey, oh, there's two x values that are the same that lead to something different. Okay, let's say you have this graph. Let's look at what that means to have these 2 points that are messing up my function. Let's find this point here, -1, -2. Okay, so that's this one right here. This is C. Okay, now because D also has a -1 for an x value, it's up here now. What do you notice about those 2 points? In fact, what's always going to be the case with 2 points that have the same x value? Well, let me just throw one more in there. What if I put point E and I said it was -1, 2? Look at where that's going to fall. Left 1, up 2. Okay, see how they all line up vertically? Okay, if you ever have points that line up vertically like that, that's going to mess up your function. You can't have that. You can't create this situation where points line up on top of each other. I'll know that that will mess up my function. Now that's actually a handy way to check to see if things are functions. Now here I have a whole bunch of graphs we're going to try. Now these are not nice sets of ordered pairs. And so when you see a graph, and this is kind of like the, I don't know what we're up to, 3rd, 4th, 5th thing that is in this lesson, but we're going to test and see if any of these are functions or not. All right, so to do that, we're going to use what we call the vertical line test. And this works great if you're looking at graphs. So the vertical line test says that if you run a vertical line across your graph, it cannot hit, so let's say in our notes it can't hit graph more than one spot at a time, let's say. That's what we use our vertical line test. So we're going to get ourselves a vertical line. All right, so here's my vertical line. And I'm going to basically just run it across the graph. And as long as it will only hit the graph once at a time, I'm good, and it'll be a function. But if it hits more than once, then basically what it's doing is it's got a point on top of another point, and I know that that would mess up my function. So right here, like boom, it hit my oval one time. Great, that's fine. But as soon as I keep sliding that across, now it's hitting this graph down here, but it's also hitting up here. Those 2 points would be on top of each other. That could not be a function. So this one, I would say, is not a function. All right, let's take that vertical line and keep going. Let's come over here. Now this one, it's hitting my graph once, once. Oh, it's turning around, but it's still only hitting the graph once. I think I'm okay. That looks all right. That only hits one time. I don't have any points that end up being on top of other points. So yes, that's a function. Let's try the next graph. Okay, so here we go. We're starting off and we're kind of down low. It's hitting that arrow spot. That arrow just means it keeps on going in that direction, and that's fine. And so I'm good so far, but about here I start running into trouble. Do you see that my vertical line is hitting the graph multiple times? It's hitting right here, it's hitting right here, it's hitting right here. I got trouble. All those points lie on top of each other, and so this would not pass a vertical line test, so I would say no, not a function. All right, let's try one more here. As this one slides left to right, does it ever hit the graph more than one time in a particular spot? And as I go left to right, I think I'm golden there. That's a beautiful function right there. It passes the vertical line test. Okay, you try this next one down here. Visualize. Now you're not going to have a vertical line, though some people use a pencil and kind of run it across their graph. The software moves that line for you. It works kind of slick, but I'll run it across and then you decide if you think that's a function or not a function. Okay, you should be saying yes, that's a function. It only hits the graph once at a time. All right, last one. What do you think on this? This is a different type of graph. It's just ordered pairs. There it hits A. Oh, there it hits C and D. Remember, this is the same graph we had earlier. There it hits B, and that's okay, but right here when it hits C and D at the same time, that's not going to work. So no, not a function. All right, the next thing that is discussed in this lesson is still talking domain and range here. You can see it says determine the values in the domain and range of the relation. Okay, so notice they use the word relation here instead of function, because right here I already know that's not going to pass the vertical line test. It's not a function, so they use that word relation. I can still do domain and range. Now last time I did domain and range, it was nice because they had the table or the ordered pairs, and remember that the domain is all of the x values. Okay, so when you're doing your domain here, the problem is with these types of relations that aren't listed as ordered pairs but instead are graphs, I have to imagine, man, there's a lot of points that would have been plotted to create this oval. And they don't have to all come out pretty. You know, there's nothing that says they have to be nice integers. I might have a 7.3 here and a 1.2 or something might be that ordered pair. So they're going to be a lot, an infinite number actually, of points that create this graph. So I can't really list out as in ordered pair format all the points that create this. So when I do my domain, I'm not going to list out numbers. My domain is my possible x values. Okay, so my x values, I'm actually going to write it as a range of values instead of as listing out specific numbers. So what I'm going to list for my x's, I'm going to first write whatever the lowest x value is, comma, and then I'll put whatever the highest x value is. Okay, and so when I do my range, remember the range is the possible y values, so this will be the lowest y value that is shown in the graph, and then I'll put the highest y value. It's kind of called the lower bound and the upper bound. So I'll put the lowest number and then the highest. Now, then what you do is once you find what the lowest and the highest are, you will either use parentheses around them And this goes back to when you did your inequalities. You're going to use parentheses if it doesn't actually equal that value, but you'll use brackets if it does equal that value. So not only will I have like this lowest and highest, then I'll put either parentheses or maybe I'll put brackets around those. And I might have one parenthesis and one bracket, and that's okay. All right, so here we go. So what I'm going to do is I'm going to maybe create some lines, and I don't know, you don't have to do this, but maybe sometimes this helps you see what's going on. All right, so here what I'm going to do with this line is I'm going to just, this is not vertical line test, I'm not doing that. What I'm doing is I'm going to grab this line and look at what's the farthest, because I'm doing domain, what's the lowest x value. Now my x-axis is horizontal, so I'm looking at what's the farthest to the left, the smallest x that's on this graph. And so if I scooch it over to here, oh, it looks like right there is the farthest to the left this graph ever goes. And so if you look at your number line, that's at 6. So the domain, the lowest x value is a 6. Now, does your graph actually touch at 6? And the answer is, yeah, it does. So since it actually equals 6, we'd use a bracket on that. Okay, now let's go see how far to the right this goes. I suppose I probably just messed that up because I can't move my line very well now. Okay, that's all right, we'll make it work. Move this all the way to the right of your graph and see how far to the right does this go. Oh, right there it stops. So what's that x value? That's the highest it can get, and that's a 10. Okay, so then I'm going to put as my highest x value a 10. And since it actually touched at 10, I'll put a bracket. Okay, so now let's try this and do our range. And it's the same idea, only since I'm looking at y values, I'm going to look at what's the lowest y value. Okay, so the lowest this graph ever gets is about right here. And so I'm doing the y value. What is that y value? Looks like it's a 1 right there. Okay, and then I go up to see what the highest y value is, and it hits about right there. And so if I look at my y-axis, that hits at 7, and it does actually hit both at 7 and down here at 1. And so the range of y values that I have looks like it goes anywhere from 1 to 7, and it does equal those values, so I'll do brackets on that. So my range goes from 1 to 7. Okay, this is really probably the hardest thing as far as what I'm always counting this wrong, I feel like on the tests and stuff, about getting this domain and range from a graph. And once you get the hang of it, it's pretty easy. But if it doesn't make sense, then it's not so easy. I want to do several of these, and I'm going to do different types, so they're not all going to look like this first oval did. So stick with me as we go through the different options, what might happen. All right, so let's try the domain again for this next graph. Okay, so I'm going to go with my domain, that's my x values. So I look at how far left this goes, because my x-axis goes horizontally. So I'm looking at what's the lowest x value. Well, my line keeps going left, and it actually keeps going left and left, and even though my graph stops here, the arrow tells me that it's going to keep on going farther and farther and farther and farther to the left. So I don't think I have a boundary. There isn't a lowest value. And if you look at this and you figure out what your highest value is, this thing keeps going to the right, keeps going to the right. Let me move it up here. It keeps going to the right. And even though it hits right there, that arrow says it's going to keep on going, so this is going to keep going to the right. I don't have a lowest x value or a highest x value. They go on forever. And so what that is then, when you do your domain, that means you go from negative infinity to a positive infinity. there is no boundary, no lower bound and upper bound. Now, because infinity is not really a number, I don't put a bracket. It doesn't ever actually equal infinity. So I'll do parentheses. Every time I use infinity, I'll have a parenthesis. Okay, let's look at our range. The range is my lowest y value. So if I look at this graph and see how low it goes, well, remember that arrow says the line keeps on going, so I know it's going to keep going downward and downward and downward. So I'm not going to have a lower bound. This thing is going to go up, 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 up. But it's not going to have an upper bound. So this is going to be another example for the range here that has no boundary, so it's going to go negative infinity to infinity. All right, I have a couple more. Let's keep going. Okay, so looking at this first graph, I'm going to start with my domain. My domain is my possible x's, so I'm looking at the farthest to the left and the farthest to the right that this graph goes. You certainly don't have to use your pencil or anything. It's really ideal that you kind of figure this out in your head and you look how far left will my graph go? How far left? Well, that arrow tells me it's going to keep on going, so I'm going to keep on going forever to the left. So my lower bound, I'd put negative infinity. And then I move it this way and say, okay, what's the highest x value? How far to the right will this graph go? And that arrow implies it keeps on going forever to the right. So my domain is going to be negative infinity to infinity, use parentheses. Okay, now your range on this one is your possible y values. So you're looking at how low it gets and how high it gets. So I come over here and say, all right, what's the lowest this graph ever gets? Well, actually this one is going to stop. Right there is the lowest that graph will be. So right there, that y value is 0. So the lowest my graph gets is to 0. And then I move it up and look at how high is it going to be. How high? Well, now those arrows say it keeps on going, and it'll keep going upward as it goes. I don't think I'm going to have a boundary on the upper end. So the lowest it gets is 0, and it does touch at 0. And the highest it gets is towards infinity. All right, so I'm going to say the lowest y value is 0. Goes up towards infinity. Infinity is a parenthesis, but since it touched at 0, that will have a bracket. You really got to pay attention to those brackets and parentheses. The software is brutal. Every little mistake, you miss your negative sign on your infinity, you put a parenthesis instead of a bracket, something like that, it's going to count it wrong. Okay, and then you're going to miss that problem, and that can get frustrating. So pay attention to those details, take good notes, and follow them. Okay. So this last one, I want you to try this one on your own. Go ahead and pause the video, see if you can find the domain and range. Okay, so the farthest left it should go right there, but that arrow is showing that it continues and it's going to keep working its way a little bit wider and wider, so it's going to keep going left. Same thing on the right. That arrow is going to show you that it's going to keep on going, keep on going, keep on going. It's going to get a little wider and wider, and that x value is going to keep getting bigger and bigger. So my domain is negative infinity to infinity. A lot of people like to put these 2 points as your domain. Okay, there is nothing special about those 2 points. That isn't where the graph stops. It keeps getting wider and wider. So don't pay attention to where it happens to cross there. Those are not numbers that you're concerned with. Okay, on your range, when you look at how low it goes, well, the arrows are pointing downward, telling you that it keeps on going, keeps on going, keeps on going. So my lowest range value would be negative infinity. And then you look at how high it gets, and so I track it and see how high it stops right there. Okay, so that looks like that's a y value of 4, and it does touch there. So your range should have been negative infinity, goes forever downward, but it only goes up until you hit 4, and it's a bracket on 4. Okay, so we did several of those. Hopefully that will start to get easy for you, and you won't be one of the ones that I have to count those problems wrong for. Okay, this was a kind of a weird one that they threw in there. I thought that was a little bit odd that they threw this one type of problem in there, but it's probably a nice, good review one. So they gave you, instead of giving you ordered pairs or instead of giving you a graph, they give you this equation, and they ask you questions about, is it a function, or find the domain and range. And so let's look at this one. I kind of like it because it's a nice review of what we've done previously, which is graphing. When you look at this, hopefully you sit there and you see, oh look, that's in slope-intercept form. Remember slope-intercept form? Where B is your y-intercept and M is your slope, and this is just going to graph as a line. So they give it to you like this as an equation, but in your head you're thinking, oh, that's just a line that has a y-intercept way down here at -7, and my slope is going to be 8/1 if I want to think of it as rise over run. So I'd rise 8, run 1, rise 8, run 1. Oh, it's just a line right here. Okay, so now let's answer these questions knowing in my head, oh, that's just a line. Does the graph represent a function? Well, remember, function with a graph. I do vertical line test. Would this pass a vertical line test? Sure would. So yes, it's a function. Could we determine the domain and range? Well, the domain and range, since it's a graph, it's not really a set of ordered pairs. I'm going to do the kind of the range of values like we just did. How far left does this graph go? How far right does this graph go? Those arrows tell you it keeps on going. How about your range? This is your y values. How low does this get? How high does it get? Okay, so even if they give it to you as an equation, you should be able to work through these other questions. I know, it feels like there's 100 things here. This is the last thing that we're getting close to the end, I promise. Okay, so let's go back to that equation they gave you. What we're talking, and this is might be something you want to take notes on, what we're going to be discussing here is function notation. Okay, function notation is going to look sort of like an equation, but not like this one they gave you. What they do, if we go back to the birthday party, and you think about what the relationship is showing, well, it's comparing how many tokens I have to buy in reference to how many kids I'm going to bring to the party. And so this is pronounced, when you look at it, it's T of K. It's not multiplied, it's a function notation saying, oh, this whole idea of this function is telling me how many tokens to buy with respect to how many kids. So it's telling me basically what I'm comparing. Now, I write it as T of K. If we start having generic equations, we typically use an F for function. And so what you're replacing is this y value. Over here my y value was my tokens. So I'm getting rid of my y. And I'm going to write it as a function rule. And it's really going to be f with respect to, and then I go look at what variable am I using. I'm using an x. So I'm going to replace the y with an f of x. Okay, so this is kind of one of those things. It's like, why are you doing this? Well, it's just if we have a regular equation that doesn't mean much, I don't know that there's a big reason to do that. But when we start having these equations and points mean something, like our tokens and kids, then it starts to, represent more. Okay, so most of what you're going to be doing, you're not going to have this. We're going to be using f of x. Sometimes they use g of x, h of x. Those are relatively common. I'm just going to stick with f of x. And the rest of the equation stays the same. You just have to recognize this is the same thing. These two are as the y. These two mean the same thing to us. You just have to know that f of x is the same thing as a y. And that might be something you take notes on. Okay, one of the reasons we do that is for some quick notation. What's f of 2? It might be like, how many tokens if I bring 2 kids, kind of thing. Okay, so let's try this. What this means is this 2 is replacing this x. So when they ask me to find f of 2, that just means find the y value if the x is 2. So just a fancy way of saying, hey, plug 2 in for x. So then I come down here and say, all right, so f of 2 means I'm going to put 2 in for x. So 8, maybe I'll do a parenthesis here to show multiplication. 8 times 2 minus 7. And then you're just doing your order of operations. Got to multiply first and then subtract. Okay, so f of 2 is equal to 9. If I bring 2 kids, I'm going to get 9 tokens. That kind of concept is what that means. Okay, you try this next one. Could you figure out, using this same function up here, could you find f of negative 4? Pause the video, go find it. All right, I gave you the harder one. To find f of negative 4, I have to plug negative 4 in for x. So 8, I'm going to plug in a negative 4 minus 7. Order of operations says I have to multiply first. 8 times negative 4 is negative 32 minus 7. That's going to be a negative 39. All right, let's try this one more time, because you know darn well they don't give you the easy ones. It's like, yeah, that looks easy, and then when you go do the software, it's like, what's this? All right, so here we go. Let's try a little harder one. I'm going to do the f of negative 4. You're going to do f of 2. So here we go. F of negative 4 means plug negative 4 in for the x value. So that's going to be 4, and then I'm going to have a negative 4, and it's going to be raised to the 3rd power, plus 7. Oh wait, look, there's another x. I have to put a negative 4 in for that one as well. Okay, so now, got to do your order of operations. 4, and this is going to be multiplication in here, but I got to do the exponent first. Negative 4 to the 3rd power. That's a negative 4 times a negative 4 times a negative 4. Well, negative, negative, negative is going to end up negative, and 4 to the 3rd is 64. Okay, so we got rid of the exponent. That's the first thing in your order of operations. The next thing we would do is the multiplication that happens right here, and the multiplication that happens right here. So 4, oops, I should have done this ahead of time. I don't know, 4 times 64, I think it's 264. That doesn't seem right. Is that right? No, that's not right. Sorry. My calculator's not handy, so I'm going old school here. 256. Okay, so, but it's going to be a negative 256. Plus, and then I have to multiply 7 times negative 4. Oh, that's a negative 28. Remember that we don't really do plus a negative anymore. That's really going to be the same thing as subtraction. Make sure you don't write 2 signs in a row. The software always counts that wrong. All right, so negative 256 and a negative 28. Since they're both negative, I'm going to add them together, and it's going to end up being a negative. So what is that? 284. Negative 284. Is that right? Yeah. Okay. All right, so like I said, I did the hard one. You go try. You pause the video. Can you do f of 2 in a harder problem like this one? All right, I got 46. If you also got 46, then you're good to go. If you didn't, go back and look at my work and see how you did and see maybe where you went wrong. Okay, that's all I've got. It's kind of a long, I wanted to do kind of a summary page at the end, but my summary page would probably be 3 pages long, so I'm going to let you summarize it yourself by looking back at your notes. Hopefully this helps.